In this section 3.7, page 75, we are going to talk about two applications to your business. One is consumer and producer surplus. Another one is income distribution. If you are graduating this year, I think you have learned in your business class about consumer and producer surplus, right? And income distribution, just a common sense, what we know of. Okay, then let's talk about consumer surplus and producers surplus first. So, what is a consumer surplus in your business class? How would you describe it? So consumer surplus is what? How do we measure, okay, the total benefit to what? Consumers, right? That's the total benefit. Then beyond whatever regular the expense, right? Then surplus means leftover, measuring what? The total benefit. Or it means what? The extra money they might have in the consumer's pocket, right? To spend. Then if you do business, you will be interested in this. See, with the consumer, the clients have extra money to spend, so maybe they are willing to spend on something extra you can provide it to them. So example, if say $12 product, then somebody sell for $8, so that would be what? $4 saving. Then that would be the consumer surplus. They were willing to pay $12, but now since they bought it for $8, they have $4 for saving. Then in their pocket they can spend as they like, right? So for a product, in the price that each customer, right? Customer was willing to pay. They were willing to pay $12, but minus what? The market price. Market price is $8. So the $4 saving, it becomes what? Consumer's surplus for a product, right? So that's the idea of consumer's surplus. This is just a regular common sense, right? In business world, I would think. Then for producer's surplus, what do you think? Is from what? The producer's side, right? So that would be what? Measuring here is the benefit to the consumer, right? Then what do you think? The producer's surplus would be what? The total benefit to whom? To producers, right? right? Same thing, consumer's surplus means extra money in the consumer's pocket. Then for the producer's surplus, that will be what? Extra money in whose pocket? In the producer's, right? Producer's pocket. But instead to spend them, then it will be what? To invest. Right? Then consider a product. Then for consumer surplus would be the price each customer was willing to pay minus the market value, right? Then for the product, for producer, from their point of view, will be what? The market price minus what? The price that the producer is willing to take. So for instance, okay, if the pizza producer company might willing to remain in the business by, dropping the pizza to $5 for, medium pizza, say Domino, right? But the market price is $8. But if $5, they think they can pay for everything with little profit. But if the market is willing to give $8 per piece, then so they will do what? That will be $3 extra they gain, then they can make more investment improvement. Right? So that's the basic concepts of your consumer surplus and producer's surplus, right? So we just write it in words to show it, okay? Then for our class, then what do we want to do? We want to calculate them in certain way, as a data, so you know what's going on according to the situation and show by the numbers, right? So with all this, then you must have what? How do you know the market price? Market price is according to what? Market and demand, right? So one thing is what? The demand function. Right? Then it's what? Market and demand, it's according to the supply function you have and demand function you have, then it will impact the market. If you have more supply, like now you have, all year oversupplied, then nobody is using, then the price will drop, right? Then like demand function, if you have more demand, then they can ask you with more, price for it. So for demand function, we use this one. Demand is according to what? The quantity, right? How many quantity you have, then that will be the price. So we did it before, we can say, okay, the quantity can be what? Demand of the price. Price is high, quantity is low, right? Price is low, quantity is high, right? So you can use this kind of relationship. Demand function is the relation between the quantity and the price. Or we can do the price is according to the quantity, the demand of the quantity. If you have a lot of quantity, right, demand, then price can drop. If you have little quantities, demand, your price may be high, right? We can do either way, okay? But for now, let's do this way. So if I have demand of quantity, depend on the quantity, demand of the quantity. So what do you think that is? That must be what? The price, right? So if that means we talk about the function of the quantity, then for the demand, that means what? We are talking about the price according to the quantity, right? So let's do the price when demand is Q quantity, right? So the demand price, so when we say D of Q, quantity is given from quantity to the price, right? So the demand price, so if we write it this way, that means what? We are talking about the demand price for the market at which what? Exactly the quantity would be sold, right? So our Q is what? The demand quantity. That's your items, right? How many units? And supply function, if I use Q as a reference, that's my demand quantity. If I say S of Q, what do you think? What does it mean? From the quantity to what? To the price, right? We are talking about the price, the relation between the price and the quantity. So this one is talking about what? The price when supply is such Q, right? So our S of Q would be what? Q would be the units, right, are supplied. This one is demand. This one is what? Supplied, when we talk about supply function, right? Demand function is from consumer side. Supply function is what? From the producer side. Is that right? So Q will be what? The same thing will be the demand quantity for the item. Okay? So because it's a function, usually we do what? We show a graph, right? So from quantity to the price, from X to Y. So your X is quantity, your Y is your price, right? So we are talking about both demand function and supply function. Okay, and also on the page 34, we talk about this as well. You can look back, okay? So, if we do this way, then when demand is high, price will be low. When demand is low, the price usually what? High. So it will look like this, right? So that's your price, that's your quantity. So your price is what? According to the demand of the quantity. Okay? Sometimes we use what? Price equals demand of the X. X means what? The quantity here. If we use this way, Q, because that's price, from the quantity to the price. So when we calculate, a lot of time we use X, right? Then X means the items, the quantity, okay? So when we do the problems, we need to identify things we use. What do you mean by X? What do you mean by Y? Okay, that's important to differentiate them. So for supply things, what do you think? The curve should look like what? So when quantity, okay, when the price is high, what do you think? The manufacturer will try to produce more, right? To make a profit. So when price is low, what do you think? They will produce less, right? So the curve a lot of time look like this. So price, according to manufacturer side, the supplier side, will be what? The demand of, should not be demand, should be the supply we are talking about according to the quantity. Okay? Then sometimes we write it this way, P equals what? S of X. X is quantity. Sometimes we use this. Okay? So usually more supply will be provided when the price is high. So we will look this to start as a reference for what? Demand functions and supply functions. Okay? And relatively relevant to quantities and price. Right? Okay? So, first, we just give the general idea, the common sense for what is the consumer surplus and producer's surplus. Then we talk about mathematically how would they look like as a function, as the model we are going to use, right? Then we calculate what are surplus. Okay, so let's see your page 76, how we are going to calculate consumer surplus and produce surplus by those ideas as a functions, as models. Okay, so for consumer surplus, okay, so let's see, for consumers surplus, how we are going to calculate, right? That means for the price, market price, right, consumers are willing to pay minus what? The market price. That would be their extra, right? So would be what? Consumers willing to pay minus what? The market price. That will be the leftover for consumers to spend, right? So consumers willing to pay is according to this demand function, right? Demand quantity. So it's according to the demand function is the price consumers are willing to pay, right? Minus, say, market price, we just use the B. Whatever happened in the market price. Then if we do that, okay, then if we accumulate from, say, time 0 to time A, or the item, we are talking about item now, right? For the Q, how many? Because consumers, for each quantity, they will have such a difference. If they have lots of quantities, so there will be accumulative from 0 to so much quantity, right? We are talking about the accumulation of all the consumer surplus according to the quantities, right? There to be saved for the saving of the consumers, right? So we are doing what? Against the quantity. So this one is your demand function, right? Then this one will be what? Market price. Is that right? Okay? So depend on the quantities. Then more quantities sold would be what? All the savings the consumers have. Is that right? Okay, so we are talking about total marketplace for all the money was saved by consumer in their pocket to spend, right? We want to find out. Depending on the more product was, purchased, then more saving from the consumer side. So if we look at the graph, it can be like this, okay? So we are talking about demand function. So you can look at this way. So for demand function, we have quantity, we have price, right? If it looks like this, okay, then depends on if this is a market price. Market price is here, the B, right? So let's take a look. It happens if you, for the market price like this, how many quantities can be sold? That would be here. Is that right? Okay, so this is your market price. So that's the quantity sold, because the market price, then quantities and price, price will be depend on the quantity, then that's the price. Quantity will be sold at this point if that's the market price, right? So that's the function. This function is what? P, right? P is what? D of Q, right? So if market price is B, that means what? This point is what? B is D of A, because this point of time, we say that's A. Okay, how many quantities will be sold at the market price, right? Then if we do accumulative according to the quantity sold up to a point, right? Then consumer surplus, this is the curve, the difference of the two curves. Okay, if we do the antiderivative, then this portion will be left an extra, right? Because consumer was going to pay all this price, and this is the market price. So at this point, then leftover is that much. At this point, leftover is that much. Leftover is that much, right? Accumulative means adding all the difference up, and the calculus does this way by doing what? The integration, the integral. Then we use this formula. Okay, for example, if we have curve like this, right? Say it's $12. This, and if $8 is here, right? Then take a look. If at the $12 you can sell so many quantity here, right? Then $8 you can sell. So what's the consumer surplus? That would be this portion. That's the integration. The formula is telling us we can do it this way. If you do the demand function minus the market price, then you take integral, means adding all them up accumulatively against what? Quantity, from the zero quantity to a quantity. Then that would be the consumer surplus. Okay? For the producer point of view, producer's surplus, it will look like this. Okay? So it will be what? Right? Those type of curve for the surplus. For the producer's surplus. So that's our quantity, that's our price. Then see how much is surplus the producers, manufacturers can accumulate. So if its market price is B, like this, so the quantity the producers are willing to sell, the market price is much more than that, then the leftover will be their surplus, right? So this one will be what? S of Q, right? Supplies, producers, okay, surplus. So that's our supply function. So at this point of time, market price, okay, to a point, then that would be the surplus, then would be the supply function to this point of quantity. Then if they supply so many quantity, then if this market price is higher than they are willing to sell, then that's accumulative portion, will be this portion. Okay, so the producer surplus will be what? We are talking about from zero quantity to a quantity, from what? The market price is what it is, then minus what? Supply function they are willing to take. That's the price, right? They are willing to take. Market price minus the price they are willing to take, that would be the surplus for the supplier. Okay, so against what? The quantity, depend on how many quantities. So if quantity is here, they will have surplus only portion of it. Okay, but to a point, all the way to this point, market price, if the supplies, quantity is high, price is high, then they don't have surplus anymore, right? Because they sell more higher price, then the market is saturated, then they don't have surplus anymore. So that will be how it looks according to what we have with demand functions and supplies function. That's how we calculate. Okay? Then see how we are actually use this to determine the value, dollar, how much left for suppliers and how much left for the consumers. Right? Okay, so let's see some examples. On your page 76. So for the example 1, it says what? Finding consumer surplus for electricity, right? The next one is finding producers surplus. So see how we are going to apply those methods to find the actual dollar, right? So first one, if the demand function for electricity is this, dx equals what? Demand function is this, dollars. It means what? What is your x? X is your quantity, right? Then D of x is what? The price, right? They say x is in million of kilowatt hours. And x is between what? 0 and 100 kilowatt. 100 million kilowatt. Okay? So then find the consumer surplus at the demand level of what? X equals 80. So what are they asking? It's saying, okay, if the demand level consumer needs what? 80 millions of kilowatts per hour, and the company charged them so much money for the market price, then they are willing to pay higher. So actually they save some money than they expected, right? So if let's do the graph with this concept. Okay, so this one is what? Linear. That means when x is your quantity, right? When quantity is 0, then you plug in will be what? 1100, right? Say that's your price, your demand function, dollar. So if you do the graph, it's a linear, so it looks like this. Okay? So then it says at x quantity at the level, this line is a demand function. It means what? How much dollar the customers are willing to pay. If you have a little quantity, people are willing to pay very high price to get electricity, right? But we say if we produce, electricity company produce at 80, okay, at 80 million kilowatts, at this time. So that would be the demand, right? Demand is 80. Then what's the price at that time? So market price at this point, like here, right? So when they produce 80, then that's the demand function. So what's the market price at this point? So the market price is what? At 80 this right now, right? So you plug in 80, so that would be what? 300. So what does that mean? It means at this point of time, at millions of what? Kilowatt per hour, then the consumer, right? Let's see, at the millions of kilowatt per hour, at this demand, then according to demand function, the price would be what? At the kilowatt per hour, the price is 300. Okay, so 300 means what? Your market price. So this one is what? Market price at this point of time. Okay, according to demand function, when you have provide such quantity, then price will be charged as such, right? The price. So that would be your market price. Then how do we do the consumer surplus? So for consumer surplus would be this, according to this formula. So our consumers surplus would be what? You do 0 all the way to this quantity, right? To the 80. Then for consumers demand function, then you do minus what? Market, right? So against the quantity. So you do 0, 80. So dx is that one, 1100 minus 10x minus b. b is what? 300. Okay, against x. So you use a formula. When you use a formula, you have what? dx minus b, then you accumulate it from 0 to 80. It's the same thing as this graph. This graph just help you to visualize, we say, the area between the curves. When you try to find the accumulative value between that, you do the antiderivative of these two curves. Then you find the value. That would be your result. Okay, so when we do that, we have what? 800x minus 5x squared for this from 0 to 80. So that would be what? 32. You do your math, plug in, and that would be 32,000. So what does this tell us? If electricity company produce 80 millions of kilowatts per hour, then the consumers, okay, surplus for electricity is what? 32,000. So the company provides this 80 million kilowatts per hour. Then consumers got a benefit in the marketplace, will have $32,000 more in their pocket. They can spend more later. Okay? So if it's saying what happens if the electricity company produce more, say to 90, then 90, million kilowatts per hour, they produce more, then consumers are willing to pay actually according to this demand function, right? Then consumer will have more money in their pocket. Okay? That's how we calculate the consumer's surplus. Okay, hopefully you can connect how we compute those numbers with your business class. Then let's try some producers' surplus as well. Then use this, right? Let's look the next example. Finding the producer surplus. For the supply function is such, okay, x of x equals 0.09x2 squared dollars. At the demand function, at the level x is 200, find the producer's surplus. So we use this graph, right? Then you graph your 0.02x squared, which is what? A parabola, right? Parabola like this. Then we want to find out what? The demand level at the x 200. So x is your quantity, right? At the demand level 200, then what's the producer's surplus? We use this. So it means what? From 0 to 200 quantity, then market price. We do the market price minus what? S of x, right? Then you have to find your market price at the quantity at 12, according to supplier's function. So at the 12th level, what's the market price for the demand? It's here. So this one is S of x. So you plug in S of 200, right? So the price for that 200 quantity, supplier's price would be what? You plug in is what? 3,600. Okay, so that would be the market price for at that level. That's your market price. When the demand quantity, when the quantity is 200. Okay, according to our model, supplier function is the more quantity supplied, then more price would be charged, right? So at the quantity of 200, that would be charge you what? 3,600. Okay, so That would be the market price compared to the quantity zero sales supply, price would be zero. Then the more it goes, then they have more money accumulated at the suppliers, producers side, right? So we do that. That would be 0 to 200. Market is what? 3600 minus this one, 0.09x squared dx, right? Then we use our definite integral skills to calculate the level. That would be you do antiderivative, right? Minus, then you do antiderivative of that to go to one more level higher from 0 to 200. So you do your math, you plug in, is for a 0, 0, 0. That would be your what? Produces surplus for this. Got idea? So we were talking about consumers' surplus and producers' surplus from, either side. Now we are going to talk about market and demand. So markets equilibrium, right? So what's the balance point? Then the market demands. So in a market we are talking about, right? You have what? Supply side and you have a demand side, right? They have to be balanced. So the market will last, right? So from supply side, we have what? Suppliers function, they think, right? The demand side is at the market at that time, we have demand function. So when we have demand function, it might have what? Consumers surplus, right? Then from supply side, then we might have what? Producers surplus. So as we saw it earlier, so for the demand side, right? The higher the price, the lower the demand, zero, right? This is a quantity. So the lower the price, the higher the demand. So that will be what? Our demand function, right? So from the supplier side, it would be what? The more you produce, the higher the price they want to, charge, if they can do that, right? So their curve would be like this. So this would be supplier's function. So the market price for the ideal one will be what? Where they meet the market and demand, right? So at this point, when they meet, then that would be what? Your ideal market price. Is that right? You have to learn this in your business class. Okay? Then that's our X, or we use Q. And so ideal price would be what? We say it's equilibrium, right? price? Where is the balanced price? Where is the demand and supply meet? Okay, so it means what? It means for this price, we want to find the equilibrium price. That would be the idea price. That would be what? Market demand at X, right? That would be what? The supply and demand curves when they intersect. Okay, so equilibrium price, the balance point would be what? Would be the supplier side, the supplier and the consumer side demand curves when they meet. That's how we find out our equilibrium price. Okay, at least from math perspective is this way. Then you can compare from with your business class. Then see how the concepts complement each other. Okay, so let's see some example. Market equilibrium. Okay, suppose the demand for a product is given by this. So that's our price for the demand quantity as such is saying this. The more quantities you have, the price will be dropped, right? That's as a demand function behaves, right? Naturally. And here says the supply for the same product from the supplier side, price will be what? By this function. The quantity, the more quantity is needed, then the supplier can, ask more price for it because there are demands, right? So for both functions, Q is the quantity, P is the price. Then if we have this model from different studies for the demand quantity from the consumer sides, and this one is from the supplier sides, okay, then that's the desirable model they have. Then let's find the balance point, find the equilibrium point. Means what? The market demand quantity and the market price. So we want to find this point. So it's at what? What kind of quantity is at what? What kind of market price? Balance point. Then find the consumer surplus at that time. Find the producer's surplus at that time, at the balance point. Okay? So what do? How about do some visual thing, all right, for the picture so you can kind of see it. Okay, so first let's graph the demand function. Demand function, if say 0 demand, then the price will be very high, 150, right? When the price be down to, let me see, Q is 0, P is 150, right? Then this is your Q, that's your P, okay? When the price is 0, then you have some, demand here. Okay, so you can just graph like this. So that's your demand, P equals this, right? So that's demand function. So if price is 0, that's how many people will like to have product. Then from the supplier side, then when the quantity is 0, price is 0, right? Nobody wants it. They are not going to supply any. So then they will have like this. Okay, so that's your SQ. That's your P equals SQ. So according to your business class, the balance point is where the demand and supply meet here, right? So how do we find this point? Equilibrium point means what? The market price. Is that right? So how do we find out where do they meet? Then you need to solve your P equals negative 0.8Q plus 150 and P equals 5.2Q. Solve your system equation, right? So what do we have? 5.2Q, you just replace P, substitution. 0.08Q plus 150. You move over, find your Q. So Q is what? 25. It means what? When Q is 25, then when the quantity is 25, they find the balance point, right? Then we plug in Q to 25, we find out P is what? $130, say. The product, when they sell at what? 25 quantity, Q is your X, P is your Y, right? Then $130, this is a quantity. That would be your balance point. So your equilibrium point at this point, the demand is what? 25 units and for $130 each. Okay? Then at this point, we want to consider in the marketplace, what's the consumer surplus? What do they think? What's the producer's surplus? What do they think? How much they will, left over for invest. Okay, then how much, how good the market is. Consumers have a lot of money in the pocket they are willing to spend. Okay, so according to the understanding, consumer surplus will be used by this, right? From here to here. So here it would be what? Consumer surplus. Then here would be your what? Supplier's surplus. So it would be 0 to 25. Then to find the difference, find the area between the curves, what do? We do the antiderivative of the two curves, right? The top minus the bottom. So the top one is a demand function. That's why we use the graphs to help us to do it, right? So that's your demand function minus your market price, y equals 130 against Q. Okay? Then you do your what? Antiderivative. Going level higher divided by 2. So that would be 4Q squared plus 150 minus 130, 20. Antiderivative Q from what? 0 to 25. Okay, then you will have what? $250 for this product. Okay, for the consumer's surplus in the market price total, right? $250. Then for the supplier side, we call it what? Producer's surplus. Will be what? Will be this portion. So the difference of two curves, 0 to 25, top one minus the bottom one. Top one is the line, that will be 130 minus what? The bottom one would be the red line, 5.2 Q, right? Against Q, then you do your antiderivative, so minus what? Divided by 2, up to one level, 2.6 Q squared, right? Then do 0 to 25, that would be what? 1625. So that would be your producer's surplus. At this balance point, then you understand the market better. You know how much consumers are willing to spend at this point, right? At the market price, and how much producers surplus they have potentially for investment. Okay, so that would be this one special applications we use for from our integrals. The skills, different skills we learn to apply to the problems and situations. Right? Let's look at the page 78. Present value of a continuous stream of income. Another place we use the definite integral is for figure out the present value of a continuous stream of income. Okay, so when do you have a continuous stream of income? Say, if you have a rich grandma, she put the trust fund to your account for the next 20 years. Okay, so steadily, each year she will put, say, okay, $20,000 in your account. And each year is $20,000 for the 20 years. Then you wonder, what's the total value of today? Consider 20 years later, that would be the total. But in terms of thinking about 20 years later, what it's worth for today. That's what he's saying, present value of a continuous stream of income, right? So let's take a look. We have what? Because you put the money in, say, every year, right? So we would do what? We can do continuous compounding, or we have what? Periodic compounding, right? Formulas. So different formulas. Remember, if we calculate as continuous stream, so you calculate the continuously. If you have today, you put the present value, right? Your principal in or present value, then consider the future value will be what? P times e to the RT. That's how we use e a lot of time, right? So for the future value, total value, say $5,000, 20 years later you have $5,000. Then how much it worth as of today? Right? That's a present value. So if I want to calculate a present value, so present value would be what? Your future value divided by ERT, right? That would be future value times negative RT, right? We use negative exponents this way. Then if periodic compounding, that would be what? Future value is present value times what? 1 times your annual rate divided by how many times a year, then times what? Total compounding time, right? Compounding how many times. So we know P is your what? Present value, or we call it principal, right? R is your annual rate. Then M is what? How many times you will compound per year. We call it period per year. T is your years, right? But from the future value, we want to calculate the present one. That will be what? Present value will be future value divided by 1 plus R to the N over M T, right? Okay, now we wanted to know if your grandma put $20,000 in for 20 years, okay, how much it is worth as of today? That was the question, right? So for continuous stream of income, so CT, if CT is according to the time, then how much is a continuous stream of income, right? Dollar per year. Then T is the number of years from now on. So the present value here is doing that, right? But this one, just one future income, one present value. One future value, one present value. But this one, because when you put a $20,000, first year, second year, another 20,000, then for 20 years, they accumulate the interest differently, right? Not everything is the same. So you will use this formula to calculate the present value of a continuous stream of income. We do this 0 to how many years? You do like this, right? So future value. So future value is what? That's the future value, right? For each one. This is 20 years later. This is a year later. That's the value. So you do the value at the time, okay, to do the e to the negative RT against the time, then that would be your present value. You will use this formula to calculate your present value. That's what you need to know. All right. If you want to know why, you might want to study advanced, more involved calculus to figure out for your business. All right. Otherwise, you just remember the formula we are going to use. Okay. we were saying for a continuous stream of income, to evaluate the present value, we use this. Okay, we use the integrals. Somebody did a study, and that's what actually is. So look at your page 78. Some examples. It says, you have an opportunity to buy a business that will earn you $75,000 per year continuously over the next 8 years. At the same time, the money can earn 2.8% per year compounded continuously. Is this business worth its purchase price of $630,000? So somebody has such this business want to sell you, then you know of is what? It generates income $75,000 a year. Say for next 8 years, it seems fine, they can just continue doing so. At the same time, that money will earn 2.8% compound continuously. Right? Then somebody wanted to sell you $630,000. Are you going to buy it or not? If you think the simple way, right? You say, okay, $75,000 times total 8 years, that will have what? $600,000. At the same time, you say, okay, you can earn so much interest, right? And compounded continuously. So compared to this one to this one, you say, okay, very close to $630,000 right now, right? Do you think it's worth the trouble? Does it value that much? Because $600,000 would be 8 years later. But consider the interest, compounded continuously. You might think, oh, it's worth or not. So according to the concepts in the business world, they say, okay, how we are going to calculate continuous income, right? Continuous stream of income this way. So they say, okay, let's compare what it's actually worth. So they say, okay, I'm going to compare this. According to 0 to 8, all right, continuous stream of income is $75,000. Then you do E, negative annual rate. All right, R is this. T is your variable because 0 to 8, right? Every year is different. So against the time, so you do your integral, right? Then do the exponential function. You do the chain rule, right? Then you do a definite integral from 0 to 8. So it ends up, you do, plug a number in, you find out is what? 537,548.75. And they want you to pay $630,000. Do you think it's worth it? You say, not worth it. Right? That's how you look at it. So at the same time, let's do the analysis. So you can do it this way. Analysis and estimate. Okay? All right. So for your answer key, page 78, your answer key is wrong. Okay? What happened is I copied the numbers from a book. Then the book was wrong. When I did the analysis, it didn't make sense to me. Okay, then I realized they calculated wrong. Okay, they calculate becomes $670-some thousand. Okay, so let's do the analysis, see what happened. So if I do say after a year, right? If I say after, that's the years. So I say after a year, I have what? 75,000. Then say after a year till 8th year, I have 7 years to accumulate the interest, right? So it's compound interest. I mean continuous compounding. Okay, so we use what? Future value equals PE to the RT, right? So I say, okay, for the first $75,000, and after eight years, after the first year, then till 8th year, so for that money, I should have what? I should have 91239.52. Okay, then second year, I will have 75000 e to the 28 for the 6 years, right? After second year till 8th year. So I will have 8872025. Okay, I just wanted to write down all the numbers so you can see how the analysis can be done. Okay, so I have 86275, 270, and 53. You should be able to plug in this formula to your spreadsheet. Then you can put all those years, 7, 8, then you put this number, then you will generate all the numbers for you, right? So for this year, for the 7th year, after 7th year, then I will have 1 year left to accumulate, right, continuously. So then this one, if we do the analysis this way, so I have 75,000. Let me give you all the numbers for you to compare. Okay, so that's how we usually analyze the situation. 888, 46, 81, 572, 17. It's sometimes a little bit tedious, but you know, money world is that way. So that's 77, 129, 68. Okay, so when I add all this up, I say if I think this way, my future value would be what? About 663,140,44. Okay? Then I say, oh, my future value is this way. Then I took a look. If it says, according to the formula, I should get a future value about that, right? If I have $75,000 year after year. Then it says, at the end, I have more than $600,000, but how about now? It says, even with the interest, it only worth $537,000 instead of what people want from you, $630,000. It's a $60,000 difference. Then I say, okay, how about I use this? This is my present value. So my future value is what? Present value times what? E to the RT, right? So I plug in this number, 57548.75. I times E to the R is this one, right? 0.028 for 8 years, right? According to the formulas. So I should have what? 672,511.66 So if I have a value, present value is this way, if I can gain 2.8% each year for next 8 years, then its equivalent value would be $672,000. Then I look at this according to what I analyzed. I said, 672,000 and 663,000, close, right? About 12,000 difference. But I was thinking if it's a continuous stream of income for, first year is 7 years later, right? But I was thinking, $75,000 I get may not be at the end. I might accumulate from the beginning, the first year, then continuously. That's called continuous stream of income, right? I say, what happened if I do the average? Because I might start to get some money till the end of year. So I say I accumulate the interest 2.8%. How about count it as 7.5 year? Then here I use 6.5, I use 5.5 year, then I use 1.5 years, then I 0.05 years. Then end up, I have those numbers, okay? Just write it for you. 525.85, right? This one I will have 97116, right? Then for this one, I will have, let's see if you can see it better. Okay, because those are not on your answer keys. Okay, 48682. You can use the spreadsheet, then get all those numbers. You better know how to use them. Use Excel. Okay, so that's part of your future. So this one is 80,438.11. Then this one is 78,217.05. This one is 76057.38. Okay, when I do that, then I add all them up. My future value is what? 672 and 489.70. Okay, so when I did that, then I used the average. Then future value will be 672,489. Then I take a look. I say, yes, right? It's getting closer. And then I realize the number for the present value is such, which the book I copied from was wrong. Okay, so that's how you do the analysis. not necessarily you do it always correct. Then you have to kind of consider of different things according to your experience. All right. And for your next page, page 79. Okay, example 3. We are going to skip for now until after the section 3.5. It uses different skills. You need to learn more advanced skills for the integrals. Okay, right now the integrals, we are using definite integrals. We only use a few simple rules, simple tools. Okay, say constant rule and what? Power rule, sum and difference rules, and exponential functions rule and log function rule, right? All those are simple ones. Then when situation gets complicated, we need to learn different skills and for solve the more complicated models. Those are simple models. Okay, so 3.4, 3.5, we are going back to those sections to learn the, more complicated skills to solve the complicated models. Okay, let's talk about the income distribution. Another type of application, we use the integrals. All right, so something called Gini index, right? If you study economics, probably will not be used in marketing or business management, but in economics, and you might use this for Gini index. What is that? Okay, it is to do certain things. So we use that to figure out the income distribution. So Gini index is used to measure the gap, okay, between the rich and poor. Okay, so economists use those. And let's see how they develop their index to figure out, okay, how many people are poor, how many people are rich. Just like this country, they say 50% of wealth is in 5%, people's hand. Now it's getting worse, right? Then you say, what's wrong with that? Rich become richer and the poor become poor. That would be a social issue to a point if, tip the balance. And just like, 100 years ago, in emperor times, then there would be a revolution. So, and because capitalism, you can, if you are rich, you can use the money to generate money easily. So, somebody studied the Gini index for that. Okay, so from U.S. Census Bureau, they studied those and say proportion of the population, okay, and compared to proportion of the income. Then that's how they see. And so if the first 20% of people, then with 3% of the income, then 40% of people with 12% of total income, then 60% would be 27% of income, 80% of people would be 49% of income. Then total one population would be whole income, right? That means the last 20% of people with 50% of income. But we know of is what? 5% of people actually with last 50% of the income. Okay, so if this way, if we do the graph, how does it look like? It will look like this. Okay, then here is a proportion of the population, right? So if this is a population proportion, okay, so then here is income proportion. So 0, 0, nobody, no income. Then if we have, say, 20%, that would be 3% of income, 40% would be 12% of income. Then it turned out like this. Okay, last portion of people with what? Huge income proportion. So those are studied from formal, right, organization, U.S. Census Bureau. And this guy is Lawrence, okay, and it's 1905, this guy, he studied this. And Lawrence curve, okay, in economies. Then they have this situation. If you have different types of curve, what does that mean? If you have this one, that's one type. Another type is here and here, okay? Then another one, so if those are Lawrence curve we are talking about, right? This is a Lawrence curve, this is a Lawrence curve. If the curve happen to be this way, what does that mean? This one means y equals x, okay? Then this one means what? Emperor time, something like that. Here is what? Average, so pretty even. Here means what? Population, right? All the way to the last point, got everything. That means what? Only one person with all the income. Nobody else has anything. So if the curve like this, that means what? Pretty even. 50% has 50% of income, 100% with 100, 20% with 20. Okay, so we have situation like this. If this one, it means what? In the middle. That means what? Absolute equal line. Absolute equal. Okay, everybody get the same income. Something like that, right? usually the curve from Census Bureau, it looks like that. So usually curve will look like this. This one will be actual curve, right? That means most people are poor, then rich people, you know, small percentage of people with a lot of wealth. So actual curve looks like this. So that's Lorentz curve is given this way. So he developed this concept, okay? Lorentz curve give what? The proportion of the income earned by the lowest proportion X of the population. So the curve he's talking about is this one. Okay, the proportion of income earned by the lowest proportion X of the population. So population is your X, then proportionally of the income, that way. And the Gini index is calculated this way. So the Gini index is this way. 0 to 1, because we just do 0 to 1 portion, 100% portion, so 20% portion. So it's from 0 to 1. Then we do X minus Lorentz curve to the dx. Okay? So then the reason also they multiplied by 2. So this one is what? Y equals X, right? This is Y equals X. Then this one is what? Lorentz curve. Okay, so X minus this. Take antiderivative. So Gini index developed like this. If we find it between 0 and 1, then top curve minus the lower curve, which is what? Would be the area between the two, right? From the calculus concept we learned in previous sections. Then they multiply by 2. It's given. This is however it's given. They say, okay, you calculate Gini index by using this one, okay? And they want to get the number, a number, and between 0 and 1. So we multiplied it by 2. Okay, it's just a number index for reference. So when we have this situation, take a look. If it's absolute equal for everybody, that means everybody makes same income. So then that would be this one, right? Lorentz curve would be what? Lorentz curve would be, that's your Y equals X. Then you do the Gini index. That would be what? 0, 1, X minus X. X is your variable, right? We try to find that the X is the portion, right? proportion of the population. Okay, so if you do that, then 0, so that would be, you plug in, and it's 0. All right, if this situation, absolute, okay, inequality, that means everybody has nothing, one person has everything. So if we do the Gini index with this, right, only last person has everything, you end up your Gini index is 1. Okay, so if it's more close to this times 2, okay, if it's more close to this line, that means everybody's income is more close to each other. If it's inequalities, then to 1. So if up to higher number means more inequality. Okay, if more close to 0, it means what? More equal. So if you look at page 80 question, does a higher Gini index means the greater or lesser inequality? So it means what? The higher the Gini index is, it means what? It's greater the inequality. Okay? So that's what I mean. So we use the Gini index with this formula to calculate, okay, the inequalities, income inequalities. So let's just look at some examples on your page 80. So find the Gini index. Here says the Lorentz curve for income distribution in the US in 2012 was approximated this Lx equals x 2.78. Okay, find the Gini index. The source is Census Bureau. Those are formal data. So some economists studied at that time, you know, they, according to the population, right? Then here is the income. Compare population to income by percentage. So when they did the study, then they find out the curve is that way. Curve is that way, somewhere there. Okay, with this, what? It's almost like an x squared, like a parabola. All right, so then if the model Lorentz curve is this way, then we can calculate the Gini index by the formula this way, right? So the Gini index is what? So it's 2 to the 0 because it's a proportion by percentage. So we do what? It says you just x minus the Lorentz curve, x minus x 2.78, then take a dx, right? Then this is x squared divided by 2, right? Then Gini index, so we just do what? Do the antiderivative of this would be 2x squared minus 1.78, right? Up one level, right? then you do 0 and 1. Is that right? So you take antiderivative of this formula, so you plug in, then this is 2 times about 0.235 for this value, so then that would be 0.47. So according to Census Bureau, Lawrence curve at the 2012 population versus income, right? End up Gini index is 0.47. That's 2012. Then it says, second one, it says, in 1990, the Gini index for income was what? 0.43 in 1990. So 1990 is 0.43, and in 2012 is 0.47. So it asks, okay, and in year 2000, it was what? 0.45. So since 1990 has income distribution become more equal or less equal from 1990 to year 2000, the Gini index is bigger. Okay, so it means what? Less equal, right? When the number gets to the 1, because totally unequal. Next one. The Lawrence curve for the total wealth in the United States in the 2006, okay, was approximated like this. Lawrence curve is what? X to the, let me see, 9.0? 9.0. Okay, they ask you to calculate the Gini index. The source is United Nations University. So they did a study, they realized, oh, that's a pretty big power. So if we do the Lawrence curve, right, x minus x Lawrence curve, then you do dx. Then you do antiderivative of this, that would be 1/10 x 10, then you do 0 to what? 1, right? The number is 0.4. This is the integral, but we say if we do it for Gini index, so your Gini index is double of the integral, which will be what? 0.8. I need to get to the magazine to see actually this data is calculated correctly or not, whether or not they get a real data in 2006. Because 2012 is only 0.47, in 1990 0.43, 2000 is 0.45. How come year 2006 it's so high, so, you know, unbalanced? So, but we can look at the business magazine in year 2000. Maybe we do Google search to do the Gini index for the, from year 1990 to 2000 to 2012. See how accurate the data is. All right. So that's how we use what? The integrals. Okay. To do 3 things we have been doing for this section. One is consumers and producers surplus. Then we also calculated what? The present value of a continuous stream of income, second thing. And third thing we are learning is what? Income distribution with Gini index. Okay, so that would be our section 3.7.